Aim of this experiment is to study the effect of acetylcholine on frog's heart. Objectives of this experiment are to record and understand mechanical activity of heart, to understand chronotropic and inotropic effects, to understand mechanism of action of acetylcholine on heart, to understand the terms bradycardia and tachycardia. Acetylcholine is a major neurohumoral transmitter at autonomic and somatic sites. Acetylcholine, like parasympathomimetics, influences heart rate and force of contraction. Acetylcholine acts through muscarinic receptors located in the heart. Acetylcholine hyperpolarizes the pacemaker cells and decreases the rate of diastolic depolarization. Because of this, the rate of impulse generation is reduced, which leads to bradycardia. SA node is pacemaker of human heart which regulates heart rate. Acetylcholine reduces rate of depolarization of SA node and thereby reduces heart rate. You can see the gap between two action potential peaks is more in presence of acetylcholine. Acetylcholine also reduces atrial and ventricular contractility by acting on cardiac muscle. Acetylcholine increases potassium permeability, which leads to hyperpolarization and decrease in contractility. Acetylcholine reduces force of contraction of cardiac muscle along with heart rate. By increasing permeability to potassium ions, acetylcholine hyperpolarizes cardiac muscle, which leads to decrease in contractility. We have already learned the isolation technique of frog's heart preparation. For studying effect of acetylcholine on frog's heart, perfuse the heart with frog ringer solution. Now start the drum and record normal contractions of heart on smoked paper for 1 minute. From the pattern recorded on the drum, you can see contractions of cardiac muscle and relaxation of the same. This event of contraction and relaxation is observed in the form of a single peak. Upgoing part of peak represents muscle contraction and reverse indicates relaxation. In these tracings, the number of peaks per minute indicates rate of contraction of heart, whereas height of a single peak indicates force of contraction. You can see that all the peaks in the tracing are of the same height and at the same distance. This means contractions are rhythmic and with normal tone. Now, stop the drum, inject zero point 0.1 ml of acetylcholine solution into the cannula. Start the drum immediately and record the response of heart on the smoked paper for 1 minute again. You can see that the rate of contraction and force of contraction of heart reduces due to acetylcholine. Also observe the rhythmicity and tone of contraction. Repeat the same procedure by injecting zero point 0.2, zero point 0.3 and zero point 0.4 ml of acetylcholine. Allow a time gap of 5 minutes between two successive doses to wear off the effect of earlier dose. From these observations, we can say that acetylcholine has negative chronotropic and negative inotropic effect on heart. Thus, cholinergics find application in tachycardia. You have learned that acetylcholine inhibits heart functioning by decreasing its rate and force of contraction. Acetylcholine mimics muscarinic action.